Okay, for this question on coordinate geometry, alright, we are required to find a few things given the diagram. Okay, now, firstly, I'll write out the two equations that are given to us. One is of the line BC, which is equation 1, and the other one is of line BE, which is equation 2. Now, the first thing I want to find is the coordinates of C. So solving simultaneously these two lines will give me the coordinate of C. That's because they intersect one another at point C. So solving simultaneous equations by substituting equation 1 into 2, alright, I will get 14x is equals to 28, x will be equals to 2. So y will be equals to 3 multiplied by 2 minus 3, which is equals to 3. So the coordinates of C as required is 2 and 3. Next, I would like to find the coordinates of A, B, D, and E. So making use of what I see in the diagram, alright, I let the A coordinates of A to be x1 and y1. Since A and C has a midpoint of M, alright, I can solve for the coordinates of A by using the midpoint formula. So 2, which is the x coordinate of C I just found, plus x1 divided by 2 has to be equals to the x coordinate of the midpoint, which is 5. Similarly, 3 plus y1 over 2 has to be equals to 5, which is the y coordinate of M. Solving, x1 will be 8 and y1 will be 7, which is the A coordinate, the coordinates of A. Next, I would like to solve for the coordinates of B. However, to do that, I'll need to solve simultaneous equations by obtaining an equation first of AD. So, gradient of CB, from what is given to us in equation 1, I know that it is equals to 3, because y equals to 3x means the value of the gradient is 3. Equation of AD, the gradient of AD will be the same as gradient of CB because they are parallel. So equation formula, equation of AD will be y minus the y coordinate of A, which we just found earlier, 7, will be equals to 3 times x minus 8, which is the x coordinate. Simplifying, I'll get the equation of AD as y equals to 3x minus 17. So since I already know the equation of CD, which is actually what I've indicated earlier in equation 2, they intersect at point D. So solving for substituting 3 into 2, I'll be able to get the coordinates of D. So solving, I'll get 14x equals to 98 and x equals to 7. Y will be 3 times 7 minus 17, giving us y equals to 4. So the coordinates of D is 7 and 4. Next, I'll be working out the coordinates of E. So similarly, I'll be using simultaneous equations. Since I already know the gradient of AE, okay, which is a negative 1 out of 3, because gradient of AE has to be negative 1 out of the gradient of AD, which is 3. That's because they are perpendicular to one another. So the equation of AE using the equation formula will be y minus 7 equals to negative 1 out of 3 times x minus 8. I'm using the A coordinate as my reference. So solving, 3y will be equals to negative x plus 29. So to find the coordinates of E, I will solve for this equation, equation 4, by substituting it into equation 2, because they meet and intersect at point E. So 8y equals to 42 and y equals to 5 and 1/4. And the corresponding x value will be 5 times 5 and 1/4 minus 13, which gives us x equals to 13 and 1/4. So the coordinate of E is 13 and 1/4 and 5 and 1/4. Lastly, to find the B coordinate, I'll use the midpoint formula. So letting B to be x2 and y2 to be the x and y coordinates respectively. 7 plus x2 over 2 has to be equals to 5, and 4 plus y2 over 2 equals to 5. Solving for x2 and y2, I get x coordinate of B is 3 and y coordinate of B is 6. And these are my coordinates. Thank you.